Welcome back, ladies and gentlemen. Today we're going to be talking about a real-life application and how we can use the Pythagorean theorem. So a lot of times when you're watching film, you're studying, you're going to be trying to figure some things out that help you, be able to do placement versus athletic ability, things like that. And really that's where you get into the study and use of mathematics to really help you increase your ability to compete. So let's talk about an example here. You design a football play in which a player runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. Your friend runs the play as shown. Did your friend make a 90-degree turn? Each unit of the grid represents 10 feet. So this tells us a lot. It tells us that corner of the end zone is right here. Your friend starts here, runs down, and then cuts and gets here. This is where he makes the pass or the catch, right? So what we have to do is determine, is this 90 degrees? So I'm going to put a question mark there because that's the main question. So what I need to know is what's the distance here versus the distance here to be able to find, is this a hypotenuse that is across from a 90-degree angle? So there's a few ways we can look at doing this. The simplest way that I can think of would be the distance formula. But again, we're not concentrating on that. So we're going to do this a little bit more, what would be complicated, so we can really appreciate the idea of the distance formula. What I can recognize, if I'm going straight up and down, then here's a line, and here's a line, and this has to be a 90-degree angle. I can figure out how far down I go here. And remember, these are units of 10. So 10, 20, 30 units down. Now, I'm not going to use my negative sign because distance is never negative. So I don't need it. And then what I am doing is 10, 20, 30 over. Now, when I solve a squared plus b squared, this is my c. So when I solve this one, I'm going to get what c equals. So here's my first triangle. Little hint, we're going to use 3 triangles. So here's my first one. I'm going to have 30 squared plus, and let me try to color coordinate a little bit better. 30 squared. And that's going to equal my c squared. So 3 times 3 is 9. Or 9, I almost said 90, 9 and 2 zeros. So this is actually going to be 30 squared is equal to 900. And that's going to happen twice. Now 900 plus 900 is going to be 1800. And I'm just going to choose this one, 1800. C squared. So what I got to do is find out this c, and by doing the square root. Sorry, I was looking for my calculator for a second and it happened to be right beside me. I was just overlooking it. So we got 1800 and the square root of that. Not a nice number, so I'm actually going to leave it just like this. So this is equal to the square root of 1800. That's my distance right here. Okay, now I can do the same thing for this side. Since I don't know this distance yet, if I go 1, 2, 3, 4, 5 over, so if I go all together 5 over, and then I go 1, 2, 3, 4, 5 down, okay, now I'm going to find my second triangle. Now, when I do that, I'm going to get 50 squared plus, and I'm sorry if there's a lot of rattle from these pins. I'm trying out new ones. May not stick with them. And again, that's going to equal my c squared. Oh, sorry. So this meant 1800. Square root of 1800 equals C. All right. So here, I know 5 times 5 is 25, and I have 0 and 0, so 2 zeros. Do the same thing here. So I'm going to be adding another 2500. And that's going to equal my C squared. So this is 5,000 equals C squared. And then I'm going to take the square root so that it cancels to both sides, and I get the square root of 5,000 is equal to this C, or D2. Now, I'm using the A squared plus B squared and keeping the C squared, and it can be confusing because we could forget, which is why I am actually writing them up here. We got to keep track of what each one is. Sorry, that's 5,000. Why did I write 1,500? There we go. All right, so square root of 5,000, square root of 1,800. All right, now the question is, what does this need to be right here in order for this to be a right angle? Well, here we have 1,800, 1,500. What I can do is combine these. This C is also equal to the side of my big triangle. So that means it's one of my sides. It's not the hypotenuse. Or this right line right here from start to end zone is going to be my hypotenuse. So if I square this plus squared equals C squared. So what I get is this root cancels that exponent. This root cancels that exponent. So it's really just 1,800 plus 5,000 equals C squared. This equals 6,800. Sorry for rattling the camera. And now I can do 6,800 square root, and I get that nice weird number. Or I can leave it as is, and that's because I had to root both sides, so those cancel. All right, so I'm expecting for this to be a right triangle, I'm expecting this distance right here to be the square root of 6,800. Well, how do I check that? Well, here's where that third triangle comes into account. The third triangle takes us from start to end zone, 1, 2. So we have to go over 20 and then down 1, 2, 3, 4, 5, 6, 7, 8, 80. So what we're looking at here is our third triangle is going to be 20 squared plus 80 squared equals C squared. 2 times 2 is 400 plus 8 times 8 is 6400 C squared. That's 6,800 equals C squared. And what I'm looking for here, so that cancels that, is the square root of 6,800 equals C. Now, here's the nice thing. Notice how I have this C when I used these two triangles as my side. To make this one big triangle, this side had to be the square root of 6,800. According to this other triangle that I know is a right triangle, boom, boom, I had to go over twice, 20 yards, down 8, 80 yards. That also came to this same C, had to be the square root of 6,800 yards. Because these two equal each other, yes, it is a 90 degree, or my friend did run a 90 degree angle for the route. Hopefully you can start to appreciate how much work it takes, because this is kind of what geometry is like. Just to give you a heads up, when you get past Algebra 1, before you take Algebra 2, you will be taking geometry, whether that's in 9th grade, whether that's in 10th grade, whenever that is. And this is the kind of thing you'd be able to do. This is also where formulas would actually have saved us time, and I'll be able to get to that in class. If you have any questions, make sure to email those to me. Stay safe out there, guys. We'll see you next class.